Hello. I want to demonstrate now how to multiply using the Booth method of multiplication for binary numbers. And I want to show how it works with negative numbers. So I'm going to take the number 7 and the number -3 in 2's complement. And I'm going to multiply them. Now the first thing Booth method says to do is to sign extend both numbers to twice the size of the numbers. So if this is the two numbers, we got to sign extend them to, this is 4 digits, we got to make them 8 digits. So let's add 4 zeros here, and let's add 4 ones here. Now in my example, this will be the multiplier. This will be the let's write that in. Well, that's the multiplier, and this will be the multiplicand. So, the first thing we do is we take the multiplier and we're going to add a 0 to the right here. So let's add a 0. That's our sort of fictitious 0 that we add so that we can examine it. Because remember, we look at 2 digits to determine what to do. And another thing we're going to have to do is make a product. So we're going to start our product off at also twice the size, so it's 8 zeros. And the first thing we're going to do is look at the 2 digits on the right of the multiplier, and we see it's 1 0. 1 0 means subtract. So we're going to subtract this number, which is 7, from the product. In order to subtract the number from the product, we have to we have to add this number to the product, but invert it and added 1 to it. So let's do that right now. And we'll get, we'll get these 4 ones, these 4 zeros will become 4 ones. And this 0 will become a 1. And now we should get 3 zeros, but we have to add a 1, so it'll be 2 zeros and a 1. So we now add, and our new product will be, 0 plus this will be this. So this will be our new product. That is our new product. Okay. Now we have to shift left the multiplicand and shift right the multiplier. So our multiplicand will now be, let's rewrite it, it'll be now 0 0 0 0 1 1 1 0, and the multiplier will shift right this way, so this 0 will drop off, and we'll get 1 0 1 1 1 1 1 1. Note that when we shift right, we do a sign to shift right, and as we maintain the sign, we don't put a 0 here, we put a 1 here because it's a negative number. Very important. Now we again examine these 2 bits, and we see that it is 0 1. Now according to the Booth algorithm, 0 1 means add. So we're going to add the new multiplicand to this, and we're going to get the following: 1 1 1 0, and then 0 0 0 0. And if we add that, what are we going to get? Well, we're going to get 1 1 1. 1 and 1 is 2, so this will become a 0, and we got a 1 over here. 1 and 1 is 2, so we get a 0, we carry the 1. 1 and 1 is 0, carry the 1. 1 and 1 is 0, carry the 1. We're going to end up with this number. 4 zeros, and anything extra is going to be, that 1 that's extra is going to be going off the edge. So that's our new number. Exactly, that is our new number. Now we again are going to shift our multiplicand to the left, and we're going to get 0 0 0 0. No, that's not a 0, that's a 1 now. 1 1 and 2 zeros here. And the multiplier is going to shift to the right this way. So it's going to become 1, 1, 1, 1. 1, 1. Now the 1 is going to drop off. So it's going to be 1, and then that 0 will be the rightmost number there. Now we look at the multiplier and we see it's a 1, 0. That means subtract. So we got now the inverse of this, which will be 1, 1, 1, 1. Now wait a second, that is a 1. So, right, let me check that. Yeah, so there's 3, right? So that's a 1, so it's actually a 0 here. And a 0 and a 0, and then these should be 2 1s. True? 3 1s and 2 1s. Now, the only thing is we have to add another 1, so we'll add the 1 there. And now if we, because we invert them and add 1. So now we can do 1, 1, and 1 is 3, so that's put a 1 here, add a 1 here, 1, 1, and then the 1 that we brought over is going to give us a 1 here, and a 1 and 1 is going to give us a 0, and then a 1 and a 0, 0 is going to give us a 1, and then this is going to be 0, 0 is going to be 0, and 1 and 0 is going to be 1, 1, 1. So let's put our comma to separate the 4 and 4. That's our number. Now, what do? We're going to shift our multiplier again. Sorry, shift our multiplicand left this way, and we're going to get 0, 0, only 2 zeros now, 1, 1, 1, 0, 0, 0. And we're going to shift our multiplier to the right. So he's going to become, this 0 is going to drop off into the pit, going to disappear, and we're going to fill it up with 1s. So it'll be 1, 1, 1, 1, 1, 1, 1, 1. Now, the truth is, we can look at this, we can keep going, but actually, let's think for a second. If these are all 1s, according to the Booth method, all 1s means just shift, and don't add and don't subtract. So I'm just going to keep shifting, shifting, shifting forever. So I'm never going to add, so I'm actually done. Now, you could say, well, how do you know when to stop if it would be a computer algorithm? Well, we'll stop when these 1s all go off and it becomes 0. When the multiplicand is 0, then I for sure stop. But basically here, if they're all 1s, then, or all 0s, then I also can stop. So I'm done. So let's see. What is this number that I got? 1, 1, 1, 0, 1, 0, 1, 1. Well, that, my friends, is negative 21. And negative 21 is what you should get when you multiply 7 by minus 3. So we see that it works with negative numbers, which is not true if you try the same example with regular multiplication. Okay, I hope that clarifies how to do Booth with negative numbers and that it actually works.